6.2 The Types of NAT. Static NAT creates a permanent one-to-one mapping between two IP addresses. One private IP address is mapped to one public IP address. This figure shows how static NAT works. On the inside network, we have private IP addresses. The server is 192.168.10.10. PC1 is 192.168.10.11, and the PC2 has an IP of 192.168.10.12. These private addresses normally cannot be reached directly from the internet. R1 is configured with a permanent one-to-one mapping. So 192.168.10.10 is mapped to 209.165.200.226. And the 192.168.10.11 is mapped to 209.165.200.227. And the 192.168.10.12 is mapped to 209.165.200.228. For example, the server's real inside address is 192.168.10.10, but to the outside network, it appears as 209.165.200.226. In the figure, P4 wants to secure shell to the inside server. P4 does not connect to the 192.168.10.10. Instead, it uses secure shell 209.165.200.226. R1 received the traffic and performed the translation. So it translates 209 to 165.200.226 to 192.168.10.10. Then R1 forwards the traffic to the server. When the server replies, R1 translates in the other direction. So it translates that 192.168.10.10 to 209.165.200.226. Dynamic NAT also translates a private IP address into a public IP address. But unlike static NAT, the mapping is not permanent. The router has a pool of public IP addresses available. In the figure, PC3 has accessed the internet using the first available address in the dynamic NAT pool. The other addresses are still available for use. Similar to static NAT, dynamic NAT requires that enough public addresses are available to satisfy the total number of simultaneous user sessions. PAT, or port address translation, allows many private devices to share one public IP address. This is the type of NAT commonly used by home routers. The figure shows dynamic NAT in action. Inside the network, we have three devices with private addresses. For the server, it's 192.168.10.10. PC2 is 192.168.10.11. PC3 is 192.168.10.12. And R2 has a pool of public IP addresses. They are the 209.165.200 from 226 to 230. In this example, PC3 wants to access the internet. PC3's private address is 192.168.10.12. So R2 looks at the NAT pool and assigns the first available public address. So the 192.168.10.12 becomes 209.165.200.226. So when PC3 communicates with the internet, outside device sees 209.165.200.226 instead of 192.168.10.12. The remaining public addresses, the 227, 228, 229, and 230 are still available for other inside devices. If PC2 later accessed the internet, R2 could assign it the next available address. So the 192.168.10.11 will become 209.165.200.227. In this example, POT has assigned the next available port, 1445, to the second host address. As R2 processes each packet, it uses a port number 1331 and 1555 in this example to identify the device from which the packet originated. The source address is the inside local address with the TCP UTP assigned port number added. The destination address is the outside global address with the service port number added. In this example, the service port is 80, which is HTTP. For the source address, R2 translates the inside local address to an inside global address with the port number added. The destination address is not changed, but is now referred to as the outside global IPv4 address. When the web server replies, the path is reversed. In this example, the hosts have chosen the same port number, 1444. This is acceptable for the inside address because the hosts have unique private IPv4 addresses. However, at the NAT router, the port numbers must be changed. Otherwise, packets from two different hosts will exit R2 with the same source address. This example assumes that the first 420 ports in the range 1024 to 64,535 are already in use. So the next available port number, that is 1445, is used. When the packets are returned from outside the network, if the source port number was previously modified by the NAT-enabled router, the destination port number will now be changed back to the original port number by the NAT-enabled router. Here, the table shows the differences between NAT and POT. For NAT, there's one-to-one mapping between inside local and inside global addresses. And for POT, there's one inside global address can be mapped to many inside local addresses. For NAT, it uses only IPv4 addresses in translation process. However, for POT, it uses IPv4 addresses and the TCP or UTP source port numbers in translation process. For NAT, a unique inside global address is required for each inside host accessing the outside network. And for POT, a single unique inside global address can be shared by many inside hosts accessing the outside network. This figure shows a simple example of a NAT table. In the table, there are 4 hosts on the internal network are communicating to the outside network. The left column lists the addresses in the global address pool that are used by NAT to translate the inside local address of each host. Note the one-to-one relationship of inside global addresses to inside local addresses for each of the 4 hosts accessing the outside network. With NAT, the inside global address is needed for each host that needs to connect to the outside network. Well, NAT only modifies the IPv4 addresses. POT modifies both the IPv4 address and the port number. With POT, there is generally only one or very few publicly exposed IPv4 addresses. The example NAT table shows one inside global address being used to translate the inside local addresses of the 4 inside hosts. PUT used the layer 4 port number to track the conversation of the 4 hosts.